All right, in this tutorial, we are going to be working on the pathfinding element of our game. We have one version in, but I think we can do better. Also, a few users were commenting that they were having trouble with the version, and so I'm not quite sure what those issues were, but I think just rewriting the entire thing and doing it better will help. So we are going to use the A* algorithm, and in this tutorial we will start slowly building up to it by first implementing a breadth first search. So let's look at what we have now for our pathfinding method. So we will hit make and make run. So here you can see that this door has connected with this door, and it has done so, but we got this kind of odd artifact. And we'll quit and make run again. Again, same thing. So to be honest, it's been so long since I wrote the code that did this, but I think it was a little patchy. So let's implement a more robust version, and one that we will also definitely be able to use for our monsters for pathfinding. Okay, so quit. Now for our breadth first search, there's an excellent resource I'm going to recommend to you all, and that is the Red Blob Games Introduction to A*. It's an excellent tutorial. When I implemented this, I learned a ton from this, and you can see it's interactive as well. So it's an excellent tutorial. I will link to it and suggest that you use it to learn more for yourself. But I will give you a brief explanation, and hopefully it will be helpful as well. So we're going to first implement breadth first, a breadth first search. So that's the file I wanted, not grid. Okay, so here we have a grid, and let's say we have a starting position, call that S. Sorry, I'll make this bigger. Okay, so here we have a map, and let's say we have a starting position, S, and a ending position, which we will put right there. Okay, how do we find a path from the start to the X? Well, with breadth first search, how the method happens is you have an array called frontier, and here I've done Y and X to indicate it's a 2D array, and you have came from, also a 2D array. Actually, this one might be more of a 3D array, but we will get to that later. So you have two 2D arrays. You have two arrays with positions. Let's call it that. You have two arrays with positions. Okay. So to start, you look at your starting position and you add it to what we're calling the frontier. Okay? So this position here is 1, 1. So we will add that to our frontier. Great. Now the next step in the breadth first search is to go to all the neighbors. Sorry, let me back up. Okay, so the initial step is to add your frontier. Okay, so you add 1, 1. We could also keep an index of frontier, so we'll call it index. We could also keep a count. Count will be at 1, and index will be at 1. Okay? Now, that's our initialization stage. Our first step is to go to the index of the frontier, which is 1, and retrieve the position there. Okay? Now, if we haven't already visited this position, what we do is we go to all the neighbors of this position. Okay, so I'm just going to say that again. We go to our index of our frontier and we get the position. So we've gotten our starting position. Then we visit the neighbors. Okay, so what are the neighbors? Neighbors are here, 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 and here. Okay, we visit the neighbors and we add them to our frontier. Okay, so I guess we can start here and we'll do y on the left, x on the right. So this position is 1, 0. 1, 0. It's now in our frontier. We then go to this top position, 0, 1. We add it. Then we go to this position, 1, 2. And finally, 2, 1. Okay, so if this was our index here, sure, why not? So that's our index. Now we've already pulled this position, so we are going to increment our index. So that's now at 2. And our count, well, now we have added 1, 2, 3, 4. 4 spots. Sorry, 5. So 1 plus 4 equals 5. Dope. Okay, so these also have been visited. So we will add v for visited. Now, each time we add one, we do a simple check to determine if it is the destination. So if either of these boxes had the x in, we would stop at that point and we would be done. Well, kind of. But since neither of those were, the next step, we just repeat. So we go to our index is at 2. We take this position, which is 1, 0, right here. Then we visit this position's neighbors. Okay, so I guess here would get added first. How you add them doesn't really matter, but this position is 0, 0. Then we would look here. Now we're going to keep a flag to determine if each position has been visited, but since this was our starting position, it has been visited, so we won't add it. This one gets added. So we don't do anything with this. Okay, then we go down here and we see 2, 0, we add it. 2, 0. Okay, so make it visited. Now that's all. There's nothing over here, so we don't take any positions over there. So we increment our index. Okay, so index goes up. Now count, we added 2 positions, so count goes to 7. Okay, now we take our next position, which is 0, 1. So 0, 1. Now we can see here only 1 position is going to get added. This position is already in our frontier. This position is already in our frontier. We only add this position. Okay, and that is 0, 2. Okay, great. Now, again, our same steps. Index goes up, and count goes up. Okay, index is at 1, 2. 1, 2. Add the neighbors. Here's a neighbor here. That is 1, 3. And here as well. So 2, 2. Also gets added. We still haven't hit our destination point. Okay, now, so again, index goes up. Index goes up. We added 2 spots. There's now 10. And you can count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, there's 11. Somewhere I went a little off. Math, it's my struggle. Okay, so we do our next step. 2, 1. So 2, 1. Notice that there is no neighbors to add, because here that position has been visited, this position visited, and also visited. So we just increment our index. We don't touch our count. 0, 0. It's going to be the same thing. Goes up. 2, 0. Same thing. Goes up. 0, 2. Here, this is where things get fun. So this went up 2. Okay, so 0, 2. We look at the neighbors. We have not visited here. So now we visit. And look, it's also the X. So we end. We would add it to the frontier, but I mean, we see it's finished. So we're done. Okay, so this is how we traverse the grid. Now, where's the path? We don't actually see any path yet. Okay, well, what we're actually going to do then is, let's just copy this. And what we're also going to do is, while we traverse, we're going to add in our came from array, we're going to add a little flag here. So let's say for our starting position, we're going to add some kind of flag to say that came from was our first position. So how did we get to, our starting position was our starting position. How did we get to our starting position? Well, we just started there. So we need some flag to indicate that. So I'll just do -9, -9. And this isn't really going to fit, is it? Okay. Well, let's see. I'll just write down here. So our starting position is okay, this will work. So our starting position is at 1, 1, right? Now, it came from nothing. So I'm just going to use -9 as an arbitrary flag to say that, hey, we just started here. Okay. It doesn't have to be -9. It could be really anything that's not positive, or you could use a different method, but I'm just going to go with that. Okay, so then we look at the neighbors of starting position. So the neighbors were these 4 guys here, right? Those 4 guys there. So that's going to be 1, 0, 0, 1, 1, 2, and 2, 1. Okay, so these 4 guys here. Now, where did they come from? Well, they came from our starting position. So that was 1, 1. So we'll just remember that for each of these spots. These guys came from our starting position. Okay, so we've added these 4 guys. Then we have 0, 0. And obviously this is going to be an ordered array. So you can access, anyway, sorry. So 0, 0. And that came from, I think we said 1, 0. It doesn't really matter as it's not going to show up in our path. And then we have 2, 0, which is down here, and that came from 1, 2. And then we have 0, 2, which is here, and that came from 1, 0. So 0, 2 came from, 0, 1. 0, 1. This guy came from here. Then we have 1, 3. And he came from 1, 2. So again, we're just saving where each of these positions, how we got to them. We're saving that. So then finally, we have our end position, which is 2, our end position. No, this is not our end position yet. So we have 2, 2, which is here, and I guess that came from 1, 2. It would have come from 1, 2. So then we have our ending position, which is 0, 3. And 0, 3 came from 0, 1. So we have 0, 1. 0, 2. Okay, so we've stored each place that each position came from, each position. Now, how do we get that path? Well, we start at our end position now. So this is when we go through the graph, we save all this information. We now have all this information. Then we go to step 2 of the algorithm. And that is we go to our end position, okay? And we say, here, let me actually, let's clear this up a bit. So I wonder if I can do, oops. B space and replace it with space space. That work? Yeah. Okay. So okay, so we have all this information. We start at our end position now, and we say, where did the end position come from? Well, we go to our 0, 3 position, which is right here, and it says, oh, it came from 0, 2. Okay, so 0, 2 is here, which means we're going to be going like that, right? That makes sense, okay? So it says 0, 2. Then what we do, okay, we're at 0, 2. Where did 0, 2 come from? 0, 2 came from 0, 1. Okay, so this is 0, 1 here. So it's going to be the same thing. Okay, now we're at 0, 1. Well, where did 0, 1 come from? We go to 0, 1. 0, 1 is right here, and the came from position is 1, 1. Look at that. Our 1, 1 is the starting position. So, downward caret. Where's the downward caret? I don't know where the downward caret is. Oh, wait, V. There we go. Yeah. Okay, so by going to our end position, also we would go then to 1, 1 and say, well, where did 1, 1 came from? Oh, look, we got this nice flag here that says it's the starting position. So we end, we stop, and look, we have our path. So this came from, we can just follow it. There. So I hope that makes sense. And let me quickly show you this on that Red Blob Games page I talked about. So he goes through all this, and then you can see the same, see all these arrows? That's our came from, right? So at any position, you have a path back to the starting position. Okay, so now we need to implement this in our C code. And I'm going to split these two videos up. So if somebody is already familiar with breadth first search and just wants to see an implementation, they could have skipped this video. So yeah, that's it for this video, and we will get back to coding in our next video. Thanks for watching, guys.